Hi everyone, today I will talking about virtual conversion and recovery method and result on the basket dish. So if I miss make any mistake, please just forgive me for grammar or pronunciation. This is the keyword. Okay, when equal person and touch. And infiltration method equal water infiltration. And this is a scientist name equal water speed. And cardinal toxicity equal half poison. And treatment and equal symbol. So time score in transmit is this. So what is a budget? First one also called budget and C was, and second one it is so venomous it will kill you way too pain. If you receive more technical content. And third one, venom is considered to be the most deadly in the world. So containing toxic that take your heart and nervous system. And it is average lifespan in the wild up to 1 year, and size is 10 feet long and 10 inches tall. Weight up to 4.4 pounds. Its range appearance. It lives permanently in coastal water of northern Australia and goes out into Pacific. They are pale blue and transparent in color and get their name from the cuckoo-like shape of their base. Okay, technical up to 15 foot from each corner of the base and can reach 10 feet in length. Each tangle has about 5,000 stem cells, which are tracked not by touch. So this percent of the chunk on the outer layer of its body. So this is the material and method. First one is sample conversion. Totally have 5 samples is 85 millimeter distance and 19, 17, 55, 65. Okay, so we'll connect in Queensland, Australia of the chemical from each sample was used from saltwater filtration. And the other was used for the internal infiltration particles. So each particle was conducted separately for each of the 5 samples. Venom will infiltrate and first use below techniques with 4 weeks of condensation of the chemical. So second one, and saltwater infiltration. Put venom in 3 milliliter and PVE was inserted from the high-grading phase drained in 1 milliliter of water in split top with approximately 0.6 gram of 0.5 millimeter diameter speed in order to fire at 5,000 revolutions per minute for 2 minutes in a ventilator at 4 degrees. And the CV was then returned to negative and 18 degrees for further use. So third, and ethanol and nitrogen similar alcohol. So tangle will place immediately in 1 liter of absolute alcohol for a period of 13 seconds. The technical will then remove and the technical solution was drained into liquid for transport. And then lastly transfer to negative 80 degrees to pass to the 13. So this is for next And so I don't know how to say this, so this is TSH group. Second, protein celebration technique must apply to determine relax abundancy and distribution of pasture fish. And protein will visualize using sample will pass through the film and 100 V for 20 minutes, and then 20 V for 40 minutes. This is the result. The X represents the solution, while the left and the right, Y X represents the absorbed alcohol is and salt water. We cover the venom. So NaNO is blue, so, and salt water is blue. This SPS batch, protein from both salt water and NaNO recovered sample was observed in a range of 10 to 17 penta in very population. Salt water recovered venom development of protein in the size range of 14 to 15.5 penta. That were markedly apparent in all test samples. Okay, so this is a discussion. So the X represents the venom concentration, and the Y S represents the cell level. The sample from both alcohol and salt water recovery were pooled. Except for NaNO sample 1, because it endowed the cell quality, unlike NaNO sample 2 to 4 that inhibit no effect. Okay, so this is a conclusion. The salt water recovery for top version of that protocol has been underlined in several studies lead to the identification of a very characteristic. The conversion of the venom profits of the two particle venom that the alcohol recovered, unlike the salt water recovered. Venom profit led this critical venom content peak. So finally, this venom was blue blood and most genes that other animals have. So pasture continue to be a topic of investigation and still are necessary to make scientists. Thank you for your listening.
Vincent Tsai.
What is K-dot?
Maybe.
You want to know what is K-dot? The other one means maybe it's a salt water recovery venom when the silage. But I don't know how to explain this. So,
You should look for the basic information. KDA means the size of the molecule. Larger number means larger molecule. Tanya.
What is the purpose of this report? What is the purpose?
what do you say? Sorry.
What is the purpose of this?
Oh, this
Repeat.
bird. Oh, you want to know this? Oh, sorry. You want to know this bird? Okay. This bird talking about jellyfish as a vendor. If you got such a article, maybe you will die. So this is also serious problem.
Rebecca.
Please.
Repeat the question.
Or you want to know this detail. Okay. you look so water is the red, so it up to 250.
You have to point to the screen, not on your own screen, but the projector screen.
So water is low to high, so maybe in 250, and the annual echo is blue. And similar is so water. So this two research is maybe similar result. Yeah.
Jimmy.
Back to the introduction. Five species. What is the number?
Which number?
85, 90, 70.
Oh, this is
Repeat his question.
You want to know this sample? What number is that? And so this number is maybe it's less. It is less than 85 and 90, 70. Yeah, but maybe I think this is the main question. Yeah.
I don't get your point. What's your answer again?
Okay. Maybe it's
Jerry.
Our lab use 4 weeks online, longer time.
Repeat your question again.
I want to know why would then use 4 weeks now large.
Do you understand him?
so. Could you?
What was your question again?
Why would then use 4 weeks?
Oh, you said
What was his question?
this. Okay.
What was that?
You want to know technique way for weeks. Because this is a observed period. So if you want to this person in the future will have a very change or yeah, but so you need period waiting for weeks to observe. Maybe it's observe bacteria or virus.
Nina.
Material and the method score. Can you change to that slide?
Yeah.
The four.
This
Yeah. How do you separate? How do they separate material?
sample. Good.
How?
Okay.
Repeat.
Or you want to know separate protein. Okay. Maybe this is a machine. Maybe it's like a chemical to analyze. Maybe it's sodium. Yeah. So this maybe determine abandoned chemical.
Denver.
Same page. Can you explain the picture, like what is it about and what is the alliances? Because like you didn't even
Yes.
mention, yeah.
Okay. I think this look like Chinese name is like the
No, this is not.
Right? So I don't know how to explain.
All right. I will just address the most important issue in this talk, which is because you chose, actually it's a chemistry paper. It's not a biology paper, although you said the research purpose was about the venom of this animal, but actually the purpose of this study was to compare two extraction methods. One is extraction with sea salt water. The other is extraction with ethanol. So it's a chemistry paper. For that, because that was your own choice, so what was really missing in your talk was, first, you could not really tell us what this was about. This is actually a very basic chromatography result. And the result, their explanation was extremely simple. So I think this one, the comparison of the two curves, you see they are different, but you say they are the same, so actually they are quite different. That means a lot in this study. And these are the same type of sample, but extracted by two different solutions. But you cannot clarify the results. In fact, I don't even think you talk about the results. You just introduce the axis, then you just go for the next. And then the next key issue is you cannot clarify what is electrophoresis. I'm not sure whether you are interested in biology or not, but actually this kind of technique is super basic in biology studies, molecular biology, solution. So even as an outsider like I can interpret this kind of result. This is standard. This is samples. So you compare the band's position. So in my opinion, you have to use Wikipedia keywords electrophoresis and keywords chromatography. This is chromatography and this is electrophoresis. You have to understand their principle so that you can tell or explain the audience what the results were about. So far as I can tell, these are mostly, some of them were actually the bigger caption from the paper. So this is actually, it says nothing about the content. So that makes your talk almost not, it's not basically understandable because you cannot tell them the meaning of the result. So that's not the thing you need to improve next time. You need to look into the principle of the methods and then you explain the audience the method and the result. All right, and now go for the details. So first of all, I will avoid a slide like this. Although I have been telling you, you need to explain difficult words, but slides like this is not helpful because when you enter the next slide, we as the audience already forgot what this was about. So therefore, the explanation of key terms was useful only when they show up. So do not use a single keyword slide. This is not helpful. And if you want to explain tentacles, I would say instead of using Chinese characters, you should use image. Because one figure explains 1,000 words, 1,000 words. That's what I've been always telling you. And then as one of the audience asked, from your last introduction slide to your first material and method slide, you did not tell the audience what was the purpose of this study. So we did not know what you wanted to know. So you need to add a purpose slide. And then regarding material and method, I realized that some of you, when preparing your top 1 slides, you tend to place substantial focus on material and methods. Some of you might spend 4, 5, 6, 7 minutes talking about material methods. However, in my lecture about how to give a scientific presentation, I told you that this part should be kept short. The focus should be introduction and results, not material method, because these are just your approach, your method. So I would say, for material method, the best way to present this is to use a flow chart. The first step, you collect samples. Next step, you cut the tentacles. The third step, you extract the tentacle with different solution. And lastly, you do some measurements. And actually, these to me are all too detailed. Like a 3 milliliter, 1 milliliter, 0.5 gram. It's not necessary. You don't need to tell them these details. It's not necessary. You just need to tell the audience broadly what has been done. That would be good enough. So in my opinion, material method should be condensed to 2 slides. And then I need to say that this is actually the results slide. So this one should be used here because that's the real result. That's how scientists would report their electrophoresis results. They just show a figure like this. So if you want to explain electrophoresis, you should use Wikipedia and use the image theory. And then, of course, you need to do some basic work because you don't even know what KDA is. And then, again, like this figure, you explain the axis, but you did not explain the symbol, and most importantly, you did not really describe the pattern here and the meaning of the figure. So it's like you just say, okay, this is x-axis, y-axis, and then that's done. So this is not acceptable. You have to tell us what's the pattern and what's the meaning of that. So this was basically missing in your talk one. And lastly, regarding your conclusion, this was overall too wordy, too much text. So you should condense them to ideally 1 sentence, 2 sentences. And you also need to pay attention, like which one was really supported by the data that you presented. For example, here you say cardiotoxic peak. What was that? In fact, that was actually this peak too. But you did not even explain it. So that's something that is like your conclusion is not back or supported by the data you presented. All right. So that's my, I have a lot of comments, so I hope to see your improvement in your talk too. Okay, let's thank Peter.